So science in Tolc-i, this is basically a mix of questions from physics and chemistry. Okay, the total number of questions it's 10, but this is not necessarily that physics have 5 questions and chemistry have 5 questions. So this is kind of a randomized, you don't know how many questions exactly you'll receive on physics. You could receive, around 8 questions on physics and only 2 questions on chemistry, or vice versa. You could receive 8, 8 or 7, or like more questions on chemistry and less questions on physics. So it just depends from the random. And yeah, most of the questions, let me write, like around 50%. We'll just, approximate it. Usually it's around 50%, but this is not necessarily that 5 physics and 5 chemistry. There could be more questions on physics and chemistry, or vice versa. But still I'll write around 50%. And all of those questions, let me write let's say 60 to 70% of the questions are theory-based questions. Let me write it down. And this is actually really good, that 60 up to 70% of the, of your test is just theory-based questions, because anytime you have theory-based questions, you don't spend time, For example, let's say there is a question and there are 5 choices like A, B, C, D, and E. Okay, and let's imagine that there is a question, how many electron, let's say, oxygen has, or how many protons in the oxygen. And this is just, basic stuff. You will not spend time thinking, oxygen is like this, and you will not compute. You'll just right away answer because you know the answer, right? And you are not wasting time. So generally speaking, theory questions, they do not take time. Basically, you'll spend 10 to 20 seconds, just to circle the right answer. But the other, let me write 40, 30% of the questions are usually practical questions where you have to compute something. So in chemistry, it's kind of you have to balance equation. In physics, you have to kind of use formulas and compute some values. For example, there would be questions like to compute velocity or acceleration, or you have to like compute force and so on. So those questions, I wouldn't say that you can guess on those questions, but you should be able to compute. You should be able to solve practical questions. But they are less, like 70% of the questions are theory-based. So that's why you'll have more time on practice. For example, usually there are 10 questions and 20 minutes for a whole science section, but for the theory, it will not take time. And that's why for practical questions, you'll have more time. For example, for solving some problem, you will not have 2 minutes, but you will have around 3-4 minutes. All right. All right, the general thing about chemistry, like what you're supposed to know, is you're supposed to know the periodic table, the elements, like the zones, like, these zones are metals and somewhere here are gases, and how many protons in the specific, like not in the specific, I mean, there will not be questions like how many protons in this element, yeah? But usually the basics elements like oxygen, hydrogen, helium, you should know how many protons it has. All right, we'll use this table, during our practice time. So I prepared a bunch of the questions, and let's start. So for example, this is the first question, and most probably this is the physics questions. Yeah, this is the question from physics. It says an object is moving on a flat surface from point A to point B. So the length of the path covered by the object. Let's say we have 2 points. Like this is the point A, and let's imagine that this is the point B. Okay, now we have to find relation, it says the length of the path and the distance. You see that all choices contain distance, right? So we have to find relation between path and distance. So for example, let's take the path from A to B. Let's imagine that we are in the city A and we are going to the city B. So let's say we are driving a car and this is our path. Let's say we drive here, then we drive here, and then eventually we reach our point B, right? So this was our path. Okay, what is the distance between A and B? What do you think? Not path, but distance.
Just straight line.
Yeah. So the distance is, the shortest, shortest path between A and B, and the shortest path between A and B is just a straight line. So you connect it. Let me write it like this. Okay, so this green one is a distance between A and B. And okay, what is less, the distance or path? In this case, what do you think?
Distance.
Yeah, distance is much less than the path. And this is like a general knowledge, that the distance always less than path. But there could be a case where the path equals to distance. Let's imagine that we have a road, from A to B, we have a perfect path. That is just straight line. Let me write it like this. Okay, in this case, the path is equal to distance, right? In the case where the path from A to B is just a straight line. So like the general knowledge is that path usually is less than distance, but sometimes path can be equal to distance when this is the line. And yeah, this is your relation between path and distance, and just try to find the right answer here. Okay, in A it says, so the length of the path covered by the object is at least equal to the distance between A and B. It seems correct. Okay, it says in B is always equal to the distance between A and B. This is wrong because first time we considered the path like this, and it was not equal, right? It was different from distance. So C can be greater or less than distance between A and B. Okay, path can be greater than distance, but path never can be less than distance because distance is the shortest path, right? That's why this is wrong also. What about D? Is always greater than the distance between A and B. This is not always, because we found out the case where the path can be equal to distance, right? It's just when the path is straight line, it's equal to distance. That's why this is wrong. And E, it says, is never greater than the distance between A and B. Actually, it can be greater in this blue line, blue path. That's why we eliminate. And we are left with A. It says at least equal to the distance between A and B. So the best case, it can be equal to the AB, but the worst case, it's always, greater than AB, distance between AB. And this is the correct answer. Okay, do you have questions here? Should we go?
Oh, no questions.
All right. The second problem, it says a proton and electron have, all right, you just have to choose one of those, This is a really basic question. Okay, let's try to eliminate by the variance. In A, it says the same charge and different masses. This is wrong because we know that proton is positively charged, but the electron is negatively charged, right? Usually it's depicted like this: the proton in the middle and electron is in orbit, but electron can be here, 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 and here. It's just it's just a convention to draw it like this, but you should be able to know that electron is not always in orbit. It can be here, 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 and here, just random probability. All right, let's go to B. It says opposite charges and the same masses. Actually, proton is much heavier than electron. So mass of the proton is much more than the mass of the electron. That's why this is wrong. They have different masses actually. And C, it says opposite charge and different masses, and that's the correct answer. That's correct, I beg. About D, the same charge and mass, this is wrong. And E, the same charge and opposite masses, wrong. Okay, let's go for next one. What's the angular speed measured in radians divided by seconds of the minute hand of watch? Okay, we have to find angular speed. Okay, basically angular speed, is a distance covered over the time. Just anytime you have speed, just a normal speed. Let's imagine that we are looking for a linear speed, which is velocity equals to s divided by t. Basically, it says that speed, velocity, is the same as distance covered divided by the time. But in this case, we have angular speed. It's a little bit different because we are moving in a circle, right? Let's imagine, let's try to draw a watch. And we know that the watch has, minutes arrow, and it has hour arrow, right? And we are looking for a minutes hour. And we have to find out what's the angular speed of this minutes arrow, because it will be moving, right? And that's why we have to kind of think about it. Okay, first of all, we have to know that the length of this whole circle, we are taking as 2 pi. And the time, we are taking how much time it takes for this minutes arrow. Let's imagine that we are starting from the 12, right? We are starting from here, and how much time, how much seconds it takes to do a whole circle, and again come back here. And we know that the minutes arrow is basically moving, every minute it's moving by 1. And it takes 60 minutes in order to do a whole circle. So I will write 60 minutes, but we have to find out the result, in radians per second, right? So we have to kind of transfer 60 minutes into seconds. So how many seconds in 60 minutes? What do you think?
3,600.
Good. Basically, you multiply 60 by 60, and you will have 60 square second, the same as 3,600 seconds. And this is the answer. Let me try to see which one it is. In this case, this is C. Okay, should we go for next one? Yeah, the next question. Okay, it says Boyle's law states that in any given temperature, the pressure times the volume V of ideal gas is constant, right? Basically, you have to work with this equation. What it says, let me shift it upward. Okay. So you have P multiplied by V. In this case, V, this is volume. P, this is the pressure. And C, in this case, this is some constant, right? And we have to find out what's the units of this constant. So in order to do it, we have to just, bring volume to the units and bring pressure to the units, and we have to find out which one is correct. Right, how do we do it? So volume, so in units, this is the same as meters cubed, right? So for example, you measure volume in meters cubed. Okay, what about pressure? So basically pressure, this is the same as force divided by area. Area you are measuring in meters squared, and the force you are measuring in newtons. So basically this is the same as newtons per meter squared, right? And you can kind of replace, instead of P, instead of V, you can write their units, and you'll have that newtons divided by meters squared multiplied by meters cubed. This is the same as C, right? And we have to find out what's the C. So what you do, you cancel the meter cubed and meter squared, and you're left with newtons multiplied by meters, which is the same as C. So this is the answer. It is E. You have questions here?
No.